Okay, let's get back into it. So we have a sum formula for cosine, so derived via that beautiful pictorial proof. We have a sum formula for sine, derived the same way, just on the other set of coordinates, right? The y-coordinates for the sine, the x-coordinates for the cosines. And then using some flim-flammery, we've got the sum formula for tangent. And if you wanted to do the sum formula for cotangent, you would just flip this fraction. If you wanted to do the sum formula for secant, you would do 1 over all this stuff. Sum formula for sine, 1 over all that stuff. But what about difference formulas, you exclaim? Okay, so be it. If you have a difference formula, you just break out the even-odd identities. Right? Because cosine of A minus B, well, I imagine something like that's going to come into play. And indeed, it will, right? Sine of A minus B is sine A plus negative B. Sine A, cosine negative B, cosine A, sine negative B. You then do your even-odd identities, and there you go. Rinse repeat for cosine and tangent, and you've got yourself good stew going on. I'm not really going to get much into this because you are probably chomping at the proverbial bit. Let's actually use these things to find out information. Good plan. Starting first at what is the cosine of 75 degrees? What got us into this mess in the first place? And there it is. Cosine of 30 plus 45, we use our sum formulas for the sum of sum of angles in a cosine. And that's cosine, cosine minus sine, sine. I do believe. Yeah. Cosine, cosine minus sine, sine. And I don't memorize this because I too just look it up when it's written out, as you do not have to memorize in this class. So 75 degrees we could express as 30 plus 45. There's actually other ways to do it, but that is one such way. So let's see here. That is cosine 30, root 3 over 2. Cosine 45, root 2 over 2. Sine 30 degrees, 1/2. Sine 45 degrees is root 2 over 2. So I've got what amounts to root 6 over 4 minus root 2 over 4, which is about a fourth, or 0.2588 that we had expected from our calculator. On this one, right, we can do it for positive angles, negative angles, sums of angles, differences of angles. We can do it any way we choose. Right, and recognizing also that we had made this difference formula just a slide ago, let's go ahead and use that. Because negative 105 I could express as 30 minus 135 degrees. So I use my difference formula for tangent that we just made. If we don't have the difference formula, just do the sum formula for 30 plus negative 135. And you'll end up with 2 plus root 3 at the end of the day. Of course, if you don't want to be really fancy in how you simplify things, you would also just end up at root 3 plus 1 over root 3 minus 1. But if you did rationalize that denominator, as your author so does sometimes, you would end up at 2 plus root 3. At least I think you would. Yeah, we'll say yeah. We'll say that's what happens. So that is how you would use these formulas. You just find some sum or some difference that adds up to what angle you're trying to measure, and then use the appropriate formula. And there's no one right way to do it. I'm missing a line break there or something. Right? If you wanted to find the cosine of negative 145, negative 15. I don't know where that 4 came from. If you want to do the cosine of negative 15 degrees, you could recognize, well, that's 30 minus 45. So you could do the cosine, a difference of two angles inside a cosine. And that's how you would go about that. Or you could say, wait a minute, negative 15 degrees, that's coterminal with 345. I could do 300 degrees plus 45 degrees and use the sum formula for cosine accordingly. And you'll see that no matter how you use it, it's the same. It's going to be root 6 plus root 2 over 4. And believe it or not, that's all I wanted to say on this. Just three quick examples of how to use them. And you see that it's really just a matter of finding a sum or a difference that equals out to be what you're trying to evaluate at, and then using the appropriate formulas. So this is going to be a short one in comparison, but I think that's fine. I don't think anyone's going to be too upset about that. I just want to make a very short and sweet point that you cannot distribute cosine. You cannot distribute tangent. You have to use the formulas. And I'm just going to give them to you, so you really have to use them because they will be literally right in front of you every time we're together. So that's it. Let me know what you want to know, and I will see you in the next class. Have a good one.